scholars, it's good to be back with you. And today I'd like to go over how to solve systems of equations. And in particular, it's going to be systems of nonlinear equations. That sounds pretty abstract, so let's walk through this in a couple of steps. Number one, let's talk about why we would actually want to do this. What's my motivation here? Why would I want to go through all this? Number two, what does solving a systems of equation actually mean? What am I actually doing if I do this? We're going to talk about how to do this algebraically on the board, and we're going to show how to do it with pictures, graphically. All right, so let's get started. First thing I need is two equations. I just made these up. They don't have any physical significance as far as I know, but they're simple enough. They make a good sort of homework size or demonstration size problem. Now, before we get any further, I don't know about you, before I go through a bunch of mathematics, I need a reason. I need to know why. Well, the big idea is that the world runs on mathematics. Mathematics describes the world around us, from the tiniest atom down to galaxies, or up to galaxies. Why? Nobody knows. We'll probably never know. We know how, but we don't know why. For whatever reason, the world around us follows mathematical laws. It follows rules that we can describe mathematically. That's why we care. So if I can solve systems of equations, I can describe things around me that I care about. I might be able to do things like figure out what's the best route for an airplane to take to burn the least amount of gas. I can figure out how to design a bridge that won't fall over when I drive over it. I can figure out how to make an investment so I might be able to retire someday. There's all kinds of things around us that require mathematics, and a lot of them are described using systems of nonlinear equations. So if we can figure out how to do it in the simple little sort of whiteboard case, we can use that same knowledge to go out and figure out how to do great big problems that tell us something useful about the world around us, tell us something we want to know, because the world around us seems to work according to mathematical law. That's why we care. That's why we want to do this. Okay? So, next thing. What does solving a system of equations mean? I've got two equations and I've got two unknowns, x and y. So the fundamental law of algebra, I think, is that the number of equations has to equal the number of unknowns. Or more specifically, if you want to solve for n unknowns, you need n equations. I guess that's probably more correct. What does this mean? Well, what I'm trying to do here is I'm trying to find two numbers, x and y, a pair, what they call an xy pair. An xy pair, two numbers x and y, that if I plug in there, the equation is true, and if I plug in there, the equation is also true. So find two numbers, x and y, that make both of those equations true. That's what solving it means, solving the system means. So find x, y, two numbers, so that both equations are true. That's what I mean. I'm going to get my head out of your way here. All right? That's what it means if you're solving a system of equations. Now, how are you going to do this? There's several ways to do this. Like in mathematics, there's several ways to do anything most of the time. And what we're going to do here is use substitution. Substitution is exactly that. I'll substitute one equation into another one. In this one, it's particularly easy. Y equals 2x. Well, if y and 2x equal each other, they're the same thing. If they're the same thing, everywhere I see y over here, I can plug in 2x. That's okay. This equation tells me y and 2x are the same thing, so it doesn't matter which one I put in there. I can use y or I can use 2x because they're the same thing. All right, well, let's just do that. Let's replace y with 2x because they're the same thing. And let's see what happens. Oops. Not mess that up. There. Well, I went from two equations to one because I substituted this one in. I don't need this one anymore. Now I've got one equation and one unknown. Here I had two equations and two unknowns. Well, one of the rules of mathematics is that as long as I do the same thing to both sides of an equation means the two sides are equal to each other. If I do the same thing to both sides, they're still equal to each other. Let's do this. Let's subtract 2x from both sides, because what I'm trying to do is I want to get a 0 over here, because that makes it easier to solve. Minus 2x. Now subtract 2x again. That's new and that's new. But since I did the same thing to both sides of the equation, it's still an equation. The two sides are still equal to each other. So let's do this. 2x minus 2x is 0. X squared. Now it's minus 4x. It's 2x minus 2x is minus 2x minus 2x is 4 minus 4x. So now I've got an equation that looks pretty simple. We may have a shot at this. Okay, now I'm going to run out of board here. See, I'm about down to the bottom. Let me erase this, and I'm going to go over here. Now I'm left-handed, so I'm going to pretty much have to step out of the frame. Now, there's a couple of ways to solve this. One of them is that I can run this into the quadratic equation. Really what I would be doing here, remember you need those coefficients a, b, and c. It would be 1 minus 4 and 0 would be the coefficients I put in the quadratic equation. That absolutely will work. So go ahead and do that if you want. This particular case, there's another way to do it. If I want to factor that equation, let's go up to here now. I can do it this way. Okay. So now I've got two terms. If you multiply x minus, or times the quantity x minus 4, you get that. Okay, so this and that are the same thing. I just factored out the x. Well, there's a couple ways to do this now. One of them is I can say, plot it again. The other one is that I can say, well, I want this side to equal 0. Well, I can say that x equals 0, and it doesn't matter what that is. Anything times 0 is 0, so I can say x equals 0. Or I can say x minus 4 equals 0, and I don't care about that. So two choices here. One, 0 equals 0 times x minus 4. That equals 0, so x equals 0. Number 2, if you can you see this okay? I think actually one of the advantages of being left-handed, I'm out of the frame. I can do it this way. This side equals 0 as well. So x minus 4 equals 0 and x equals 4. So my solutions are x equals 0 and x equals 4. Can I see that? You guys can see that? Okay. There's my solution. That's the answer. Right? We just did this algebraically using substitution. Let's get over here. Okay? That works. There is another way to do this. I can draw pictures. The cool thing about mathematics is you can almost always draw a picture of what you're doing. You can almost always draw a picture of your problem. Let's do that. Let's get rid of all this stuff. And there was a point in mathematical history where a guy named René Descartes came along and said, you know, if you want to draw or plot x's along one axis and y's along a perpendicular axis, kind of like that, you can draw a picture of an algebraic equation. This was great. People hadn't been doing this before much. Probably somebody had, but Descartes kind of gets the credit for it. It's the reason we call this rectangular coordinates. It's the reason we call it Cartesian coordinates after René Descartes. And what he did is he said, wait a minute, if I can draw a picture of an equation, that means algebra and geometry, the exact same thing. Good day. All right, so I'm going to draw a picture of my parabola, which looks like that. Okay, that's y equals, get that out of the way, x squared minus 2x. And I'm going to draw this. That's y equals 2x. All right, now it's not proportional here. I don't quite have it equal space in x and y. Right there, that's x equals 0. Right there is x equals 4. So what this means is if those two equations, if I can find a value of x and y, an xy pair, that satisfies both of those equations, that means they occupy the same spot in space in two different places. the same y value at some value of x, and so another over here with another same value of y given a value in x. So what that means is they occupy the same point in space, both of them do, they must cross over each other. So wherever these two lines cross each other, that's the solution. So there you go. There's how to do this in using algebra and how to do this graphically. Hope this helps. We'll talk to you next time.